We left off in part 1, we explained that if we want to integrate the integral of e to the 3x differential x, we need to know that the integral of e to the kx dx is equal to e to the kx divided by k plus c, where k is a constant. So in the case where we have a function e raised to a constant multiplying x, we need to divide that function by the constant and add a plus or arbitrary constant of integration c. So in this case, our constant is 3 and is multiplying x, so we would do e to the 3x divided by the constant 3 plus our constant of integration c. As you can see right here, we have expressed it as 1/3 e to the 3x plus c. Now we're going to proceed to examine indefinite integration using trigonometric functions. If dy dx or the gradient function equals little f of x and dy dx equals sine of 3x, thus find an alternative expression for big F of x. So we firstly set up our integral sine 3x differential x, knowing that the integral of sine x dx is equal to negative cosine x plus c, and remembering that when a trigonometric integral is in the form of the integral of sine kx dx equals negative cosine kx divided by k plus c, where k is a constant that is multiplying the angle or argument inside of sine, in this case x. So when we have that scenario, we first need to integrate our sine function, and then we divide that function by the constant that is multiplying the angle, and we add our constant of integration c. So in this case, there are two rules. We have the integral of cosine kx dx. We know that the integral of cosine is sine, so we first integrate cosine from the outer to inner part, and we get that sine of the angle kx, and we divide by our constant k divided by k plus c. So essentially, you always divide the function by the coefficient inside the argument of sine or cosine that is multiplying the angle. So in this case, big F of x would equal negative cosine 3x divided by 3 plus our constant of integration c. Now we're going to aim to find a solution of the integral little f of x given an initial condition. So given dy dx equals f of x and dy dx equals 3x squared plus 5, given that the curve passes through a point 5,4, find the expression for big F of x. We firstly set up our integral. We need to use two rules of integration here, the constant rule. We can take the 3 outside of the integral to simplify our processes, and we can use a power rule too. After using those rules, we get that big F of x equals x cubed plus 5x plus c. Now we use our initial condition, the coordinates 5,4, to find the arbitrary constant of integration c. We plug in 5 for x and we plug in 4 for y. And we get that the constant of integration c is negative 146. Therefore, our original function y big F of x equals x cubed plus 5x minus 146. Now, we're going to explore another technique in indefinite integration, which is indefinite integration by inspection. In indefinite integration, we use the method of variable substitution to simplify our original integral in an attempt to ease the integration methodology. In this particular process, we identify a single element of the integral with the variable u. We then derive this element and substitute in the original function for u. So, we use integration by substitution when we find ourselves in an integral of this form. Basically like a chain rule and derivative. So if we have the integral of a composite function f gx, and that is multiplied by the inner derivative of the composite function g, we need to use integration by inspection. Okay? And this situation right here outlines in principle what this mathematical demonstration is trying to say. So imagine we have dy dx, or the gradient function, equals a cube root of x squared minus 3x times 2x minus 3 differential x, and we are asked to find big F of x. Firstly, we let u equal x squared minus 3x. Why? Because if we derive u, we can easily cancel the derivative that is multiplying the inner function. We differentiate u with respect to x, and we obtain that du equals 2x minus 3 differential x. We divide that quantity 2x minus 3 to the other side of the equation, as shown in this step right here, and then we substitute our alternative expression for the x, and we get the integral of the cube root of u times 2x minus 3 times du over 2x minus 3. Clearly, the quantity 2x minus 3 ends up being cancelled, and then we integrate using the power rule. We do not plug our value for u yet. We first integrate using the power rule, and then after we do that, we substitute the original quantity assigned to u, obtaining big F of x equals 3/4 times the quantity 2x minus 3 raised to the exponent 4/3 plus our arbitrary constant of integration c.